So this video is to recap solving proportions and then connecting what we know about proportions to be able to solve percent. So first I'll start by talking about what it means to have equivalent fractions or equivalent ratios. And when they're stated like that together, then we call that a proportion. So let's look at this first example of 2 over 3 equals 4 over 6. So visually we can see that those two ideas are the same because they're kind of describing the same multiplicative relationship between that pair of numbers. Okay, so what we're saying is that 2 relates to 3 in the same way that 4 relates to 6. Okay, so let's see what that looks like visually. So I can draw 2 and 3 together kind of like this if I look at them in two different kind of positions. So if I start here at this dot and I go up by 2 blocks like this on my grid, and then I go over by 3 blocks on my grid in the other direction. I'll make that a little straighter like this. Then I would end here. Okay, I can draw like this little triangle that kind of connects those, the starting point and that ending point like this. Okay, now if I want to look at the same thing but with 4 over 6, then I'm going to start in the same spot, but this time I'm going to go up by 4 since my top number is 4, and I'm going to go over by 6 units. So I'm just going to do that a little straighter again like this, and then I end here. Okay, so I hope you can see visually that the way that this this other fraction, the 4 over 6, looks on that grid is really equivalent to the way that 2/3 looks, meaning that in both of these I'm creating a line that's the same steepness. So if I talk about like this angle here, those two lines are creating the same angle against that horizontal axis there. So it's kind of like the word that we have for that is similar. Those are like two similar triangles that we've created, so we can see how that kind of works. Now, algebraically looking at that equation, 2 over 3 equals 4 over 6, I can see that there's a multiplicative relationship across here. So in both of these cases, I would have to multiply by 2 on the top and bottom, and that's how I would get 4 over 6. So 2 times 2 is 4, 3 times 2 is 6. So I can see multiplicatively how that works out. I can do that again with some other numbers instead of a different multiplier. Let's say I had 2 over 3, and I multiplied that top and bottom by 3 instead. Then I'll get something that looks like this. So I have 2 times 3 is 6, and 3 times 3 is 9. So we can see 2 over 3 equals 6 over 9. So let's see what that looks like on our diagram here. So if I look at what 6 over 9 looks like in this picture. So I'm going to start in the same place. I'm going to go up by 6, 1, 2, 3, 4, 5, 6. I'm going to go over by 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 like this, and I'm going to end here. So I hope you can see that this continues in that same line as the other. So again, we have that same steepness, like that same angle that's created by the lines connecting all of those points. So we can see that equivalence visually here. If I look at another supposed equation like this one over here, where we have 2 over 3 equals 4 over 5, that's not multiplicative. Here what I've done is I've added 2 to the top and the bottom. Okay, so what does that look like if I put that on the same grid? So if I start in the same place, I'll start here, and then I'm going to go up by 4, 1, 2, 3, 4, like this, and then over by 5, 1, 2, 3, 4, 5. I'm going to end here. I hope you can see that the line that's created that joins the new start and the same start and the new end is not the same steepness. Like it's not in line with the others. Okay, so we can see that these things are actually not equal to each other. So this is this key word about multiplicative, that when you're creating equivalent ratios or equivalent fractions, so setting them up in a proportion, that means that you can multiply or divide, really works the same way, the top and the bottom by the same number, and you'll get an expression that is also equal. It doesn't work for adding, and it doesn't work for subtracting either. Okay, so you can't add or subtract to the top and bottom number to get a new equation. That doesn't work. Okay, so now we know that's how they function. Now let's use that idea of a common multiplier to solve some proportions. So what I'm thinking about is, what is it that we have to multiply by in order to create that new number? So in order to figure out what 7 times what is to make 24.5, the opposite of multiplying is division. So I should divide 24.5 by 7. And that tells me 3.5. That tells me that 7 times 3.5 equals 24.5. Okay, so see how I did that? I wanted to know about multiplication, so I used division to do that. That means that I should be able to take 4 and multiply it by 3.5 here to figure out what x is, because I know that I need that same common multiplier on the bottom that I have on the top. So 4 times 3.5 is 14. So that means that this x value must be 14. Let me see how I can check my answer. So what we think is that 4 over 7 is equal to 14 over 24.5. Here's how we can check it. If you remember, we did this in class. 4 divided by 7 has a value. That ratio has a value of about 0.57. Okay? And 14 divided by 24.5 has a value of the same thing. Okay? So because I can see that these two expressions have equal value, then I know they must be equal, and x really must be 14. Okay? So that question is done. I just want to point out, though, that we could have gone the other way. The multiplier doesn't have to go across the two fractions. It can go up or down. So here I'm always going to start with the smaller number because it's easier to think about multiplication than it is to question about a division. So we know 4 times something is 7. To figure that out, I need to use division. So I'll do 7 divided by 4 and get 1.75. That means 4 times 1.75 should be 7. Let me just check that. 4 times 1.75. I'm hoping it's 7. It is. Okay, awesome. So that means that I should be able to use the same multiplier, the same scale factor over here. I'm just going to move this out of the way. So that means if I knew what x was, I would multiply it by 1.75, and that would give me 24.5, but I don't know what x is. So instead, I have to have my arrow go the other way. I need to use the 24.5 to find x. So because I'm going in the opposite direction, I'm actually going to divide instead. Okay, so I'll take 24.5 divided by 1.75, and I get 14. Okay, so same answer, so we know that we did that right. Okay, let's do another example over here. So here I want to know what my scale factor is. Okay, so I'm going to look, for me it seems easy to go here. 3 times something is 16, so I need to figure out what that number is. So I do 16 divided by 3, and I get about 5.33333. The more decimals I keep, the more accurate my answer is, so I'm going to keep a bunch. So that means that if I want to use that on the other side, the relationship should be the same. So x times that number would be 94. So that means 94 divided by that number should be x. So I'm going to use that scale factor over here. So 94 divided by 5.3333 is about 17. So we think x is approximately 17.625. Now I'm going to check my answer. So we think the answer is 94 divided by 17.625 is equal to 16 over 3. So I'm just going to check those two values. So 94 divided by 17.625 is 5.33333, and 16 divided by 3 is the same thing. Okay, awesome. So that means that we know we did that right. Okay, so that's how you solve a proportion. When we're solving problems with percent, we're going to use the same idea. We can look at percentages as proportions too, so that we can solve them the same way. So if an item has a ticket price of $124.99, how much does it cost with tax? So what I can do is I can draw this little diagram that helps me see, like if you can imagine like a measuring cup or a beaker that's full. If it's 100% full, that means it's all the way full. And if it's 0% full, it means it's totally empty. So if the price is $124.99, that's like the full price, okay? So that's $124.99. That's like the 100% of the price. What I'm curious about is how much is the tax. We know that tax is about 13% in Ontario right now. So that means I'm curious about what 13% is. So I just kind of rough it out where 13% would be on this scale. I know it's like well below half and a little bit below quarter. So I want to know what is the value of dollars that kind of belongs there. I hope you notice that this looks very similar to a proportion. Here we have a proportion of a number over a number equals a number over a number. This is the same kind of structure, something over something and something over here. So I can use that same idea of multiplicativeness to be able to figure out what the scale factor is. So let's look at the 13. So 13 times something is 100. So to figure that out, I do 100 divided by 13. Whenever I'm wondering about a multiplication, I do a division because those are opposite operations. So I'm going to take a few decimal places like this. So that means if I want to use that same scale factor on the other side, because I have the top number, not the bottom number, I need to go in the opposite direction. So I'm going to divide by that number, divide by 7.6923. So 124.99 divided by 7.6923 is 16.2487. So I'm going to round that to 25 since it's in dollars. This is all about prices. And when we're talking about dollar amounts, we always round to 2 decimal places. So this tells me that the tax is $16.25. So if I want to know the total price, then I have to take the tax and I have to add it to my total amount. So there's $124.99 is the ticket price. Then I'll add $16.25 in tax. And I get $141.24. So my problem is done now. This is my final answer. This is the total price with the tax. But I could have done this in a slightly shorter way by setting up my problem just a little bit differently. So same thing, I have this beaker. And if it was 100% full, then that would be the full price, which is $124.99. But I want to add on top of that. So I want to pay for the full amount, plus I want 13% on top. So I'm actually going to extend my beaker as if I could overfill it. So this is now 113%. And then here I'm wondering what that amount of dollars would be. Okay, so this is like the dollar side. So same thing, you can see I have a number over a number equals a number over a number. So I can treat that the exact same way that I treated all these other problems before, and I can find out what the scale factor is. So let's find that scale factor. So I know 100 times something, or actually let's go the other way just to make it interesting this time. 100 times something makes $124.99. So I want to know what that multiplier is. To find the multiplier, I divide. So $124.99 divided by 100 is 1.2499. So now I'm going to use that the other way. So this time I'm going in the same direction, so I get to multiply again. I'm going to use the same operation because I'm going in the same direction. So 113 times 1.2499 is 141.2387. So I'm going to round that to 24 since it's money. So that means that x is 141.24. And this time that x doesn't represent the tax. That x represents the tax on top of the price, so the full amount. So notice that was a little bit of an easier calculation because I didn't have to do this step here of adding the total price to the tax.